All right, so I did problem 2 for the fundamental theorem of calculus, checking Stokes and Gauss's theorem. So for Stokes, we figure out the curl of this function, and it comes out to be this: 4z squared minus 2x is the I component, j there's nothing, and k is just 2z. So for two different surfaces, I did the xy plane and the xz plane. For the xy plane, the d of a, or dA part, is perpendicular to the xy plane, but it's parallel to k. So dA would be 0 because z is just constant the whole time. And then for the xz plane, dA is parallel to j this time instead of to k. And since there's no j component at all in the curl there, then dA would be 0 for that. So then for Gauss's theorem, I did a 1 by 1 by 1 cube at origin, and this is the divergence of the function, would be 0 plus 6y plus 8yz. It's still this function up here, I just didn't write it down again. And so I showed x equals 0 and 1, y equals 0 and 1, z equals 0 and 1, because those are along all the sides of the cube. I have, for x of 0, dA is equal to negative I, and so f times dA is 0. And then for x equals 1, I have it equal to I hat, so it's also 0. For the rest, you actually have to evaluate the integral because they're not obviously equal to 0. So for y equals 0, the integral of f dot dA, where dA is equal to negative j hat, is this. Evaluated it out, we get negative 1/2. For y equals 1, same idea, but dA is equal to k hat on this one, so we have it equal to 3.5. Then, oh, I wrote that wrong. That's supposed to be a j hat right there. dA is equal to j hat on y equals 1, not k hat. I did it right in the integral though, so that should be equal to 3.5 for that part. Then z equals 0. dA here is equal to negative k. Do the integral of f dot dA, which is negative k on this one, and it equals 0 here. And then for z equals 1, it equals 2.